So what is failover clustering? It is nothing but a group of computers, just two or more, that work together to increase your availability and scalability of clustered roles. Now, a clustered role could be like an application, could be a file server, could be a clustered role. Even virtual machines could be a clustered role, just something that you want to make highly available. Now, the availability means no failure. I have a file server. If this file server were to fail, I still need the files to be available and accessible to my users. So to do that, you could have a 2-node file server cluster, which means you have 2 file servers. Either one of those file servers you connect to, you can access the same set of files. That would be availability, no single point of failure. Scalability is simply allowing for growth. If you have an application that receives so much traffic that one server cannot handle it, you could build a failover cluster that still gives you the availability, but you also now have 2 servers that can actually deliver your application data back to a user. A web server, for example. You could have 2 servers host your website and both deliver websites back. So really, a form of load balancing we can also get. But I just think of that as load balancing. Now, there is a network load balancer in Windows Server that you can create. But many of the characteristics of that you can also achieve from the failover cluster. So it does give you the bit of the load balance and high availability by not having a single point of failure. Now, whenever we talk about clusters, we don't really use the term server. Your servers will be called nodes. So I'll say I have a 2-node cluster or 3-node cluster. Simply means you have 3 servers in your cluster that host your application or your file server or whatever it is. Now, those servers are just connected to like a network, like any server would be. So you'll have physical cables, like Ethernet cables, maybe fiber, but not Ethernet, really, and by software. Now, the software is actually the failover cluster feature that we load on the server. So that is just built into the operating system. You just install that on all the servers. Now, with this, if one or more of your cluster nodes fail, the other nodes either begin or continue to process all your requests. So you could have one server fail, the other server now processes all your requests. So we'll just say we have failed over to the other server. This is why you'll see websites like Google.com. You'll probably never see Google.com crash and go offline ever, because there would be multiple servers that host Google.com, and those servers would be in some gigantic failover clusters. Now, at that level, they're using something far beyond failover clustering in Windows Server, but there are many types of failover clustering. Some of our largest clients use one called F5. Now, that is for like large enterprises. Facebook uses these F5, eBay, Yahoo. So there are numerous vendors that sell failover clustering components. Some are ridiculously expensive. Like F5, no one knows how much it really costs. Because if you go to the website and you want to find out how much it costs, they will tell you, now you have to be a large company, but they will come to you and deliver a presentation to show how this can benefit your environment. Then they will tell you how much it costs, which is code for ridiculously expensive. The failover cluster in Microsoft is built in at no additional cost, but it's assuming we all run Windows servers, where some of these other technologies, they could like failover cluster, Microsoft, Linux, any of these operating systems or products. We are just focused on Windows here with the failover clustering built into Microsoft. Now, to continue the list, your clustered roles. Now, whenever they say clustered role, they mean the thing you failover clustered. So in this example, I have I'm just going to call it server A and server B. I have some files that I want to be highly available. So I want to build a file failover cluster. To do that, I need some type of central storage. So I'm just going to say I have a storage pool. From here, both my servers connect to this storage pool. Now, they're basically going to have a map drive directly to this. So if I'm here, I'll have what's called the E drive. So if a user ultimately gets connected to server A, they access, say, the E drive or share on the E drive, they're really connected to the data in that storage pool. If you connect to server B, it has the same exact drive mapping, points back to that storage pool. Now, we can make the storage pool itself highly available. So that can be mirrored, replicated. So that would be highly available as well. No single point of failure. You would have dual cables that go to your storage pool. So at no point would you have a single point of failure anywhere in this diagram. But with that said, either of these servers you connect you to the same piece of data. So if I'm browsing a shared folder, it does not matter which server you connect to. So let's say this is the active server, meaning it's processing all your requests. The other server right now is passive, which means it is not processing any requests. It is simply listening to server A. If server A goes offline for any reason, this will flip from passive to active and immediately starts servicing your clients. So we've avoided a single point of failure. So if you reboot this server A, server B just starts delivering access to your shares. So that is the proactive monitoring, just to verify that all the other nodes are working properly. And as we said, if they are not working, another node in the cluster simply runs the workload. Now, when you connect to the cluster, you don't directly connect to server A or server B. The way it works, the entire cluster gets a name. So let's say we just call this the entire cluster. I'm just going to name it File 01 is the name of the cluster. It also gets an IP address. I'll say 10.1.1.5. So when you connect to this, you browse the name of the cluster, not the individual servers in the cluster. So now, when my user connects to this, they get passed to one of these servers inside the cluster. So I don't know if I connect to server A or B. I don't even know there's a server A or B. If I'm the end user, I just know I connect to this path and I see this share. You have no idea exactly where it was delivered from. If server A fails and server B is the one you access, all you know is everything's working. So interesting concept and pretty straightforward to ultimately set up. Another term you will see a lot is high availability, or HA. This is always expressed as a percentage of time, like 99% of the time, or 99.99%, something like that. Highly available services are considered anything available more than 99% of the time. So if you're above that, or at or above, you are highly available. Planned outages are not included. Everything has a maintenance window. You even see this with like bank sites. They'll tell you once in a while, maybe every 6 months or so, your online banking may be offline from 1 a.m. to 2 a.m., something like that. So many services have some type of planned outage. That does not get calculated against the availability time because it's not a failure, just a planned outage.